Okay, so let's look at how to apply the inverse of a function, or to get the inverse of a function, specifically in regards to the linear function. Now remember, with the inverse, the whole concept of swapping the x and the y values around is going to be very important. And when we want to draw the graphs, what will be even more important, or linking onto that, is this line y equals x. And I'll show you in a moment why it is important. So for this example, our function is negative 3x minus 9. And the question is, the first question is draw the function and the inverse function on the same set of axes. Okay, so that's what we're going to do. So if x equals negative 3x minus 9, then in order to get the inverse, we make this x and the y. Now I'll take the negative 3y across, becomes 3y. Take the x across, becomes negative x minus 9. Divide by 3, and y will be minus 1 over 3x minus 9. Therefore, the inverse function is minus a third x minus 9. Just for reference sake, I'm going to write down the inverse here at the top as well. Okay, please note that that's a 3, not a 9, because the 9 was divided by 3, therefore it's a negative 3. I'm going to draw the function in red and the inverse in blue. So the function is quite easy. You can see we've got a y-intercept of negative 9, which is right over there, and a negative graph of 3, negative 3. So this is our function. Here we go. Now to draw the inverse function, you will see there its y-intercept is negative 3, and it has a gradient of negative a third. So if you do your calculations and use rise and run method, you will see that its x-intercept will be negative 9. So now this is our inverse function. Okay, you'll notice that they intersect each other right there on the line where y equals x. And this makes perfect sense, because for the inverse we swap x and y around. In other words, for these two functions, the function and its inverse, they have to intercept where y is equal to x, because we change them around. Okay, so please take note of that. With these functions, you always have to consider what the domain and the range is. So this domain, range, and this is for the function and the inverse. Now this is quite easy because it's a straight line graph. I'm just doing this so you guys can get into the habit of doing it as well. The domain for the function is x element of R, and for the inverse, whatever the domain is, it will be the range for the inverse because x and y swapped around. And then for the inverse, its domain was also x element of R because it's a straight line, and it will be exactly the same for the function. The function's range will be y element of R. So these are your tests with inverse. The domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. And when you're doing your graphs, they have to intersect on the line y equals x. So those are your markers along the road.